Common types of networks. So networks, just so you guys know, come in all sorts of sizes. If you're talking about your house, it's its own small home network. And here you can see they say connect a few computers to each other in the internet. Well, that's not the case anymore, right? So now most of you guys probably have Ring doorbells or smart TVs. You probably have some video surveillance, maybe, where you can see the actual backyard, front door, front yard, side of the house. If you don't, there's a lot of people trending that direction. We now have thermostat controls. There's devices to turn outlets on and off, turn lights on and off. Even light bulbs are now network devices thanks to IoT. So small home networks are still small, confined to, 1,000 square feet, up to 4,000 or 5,000 square feet, but they're made up of a lot more devices now than just computers and the internet. A small office, home office is becoming a reality these days thanks to the pandemic. I don't remember what the numbers were, but there's a huge portion of offices all working from their house now. And I also read that the trend is most of those folks want to stay that way. They don't want to go back to the office. And I think that probably, for creative thinkers that can actually function in that type of environment, that may actually come true for them. Then we have these bigger, medium to large networks. There's many locations, hundreds, thousands of interconnected computers. So something you probably never thought of, but you guys go into a gas station probably on a regular basis. The gas station typically is not one. It's branded, Shell, Exxon, whatever it might be, and those are owned by some conglomerate or some large organization. So they're all interconnected and networked back to a corporate office. So Walmart's, Dollar Generals, all of these things that when we kind of go in them, we know them from the neighborhood or we know them from the environment that we're in. But those things are large networks. There's thousands of some stores. And then, of course, you got corporate offices. Some places have grown to where they're not just in one territory anymore. And then you get outside of those corporate environments that have medium to large networks, and you have worldwide networks. So you may have some organization like Amazon. There's no telling how many countries that they have physical equipment and offices in. So we're connecting hundreds of millions of computers worldwide in a worldwide network, and the internet is an example of a worldwide network as well. So you're going to throw all kinds of terms at you this semester. So there's two terms that are popular: LANs and WANs. A LAN is a local area network, and basically it's defined by a area. A LAN might be a small office like it's pictured here. So you can see the things in yellow are defined as LANs. And then they're showing you that basically this was probably some company. It's got a central location or a headquarter. USM central location would be the Hattiesburg campus. But we have a branch that's in Gulf Park. And then there's some smaller home offices where people are working out of. And not only that, you have smaller or SOHO offices that are tied back to the campus. So a LAN doesn't have to be a building. It could be a campus. So Hattiesburg campus, in my mind, is a LAN. It's a local area network. If you're within the Hattiesburg campus there, you can pretty much walk from any area and pick up the network via the air with the wireless infrastructure that USM spent money on. So they vary greatly in the terms of the size and the area covered, the number of users connected, the number and types of services available in the area of responsibility. So a small network at USM, that's probably, 20,000, 25,000 people on the Hattiesburg campus, if you count students and teachers, not counting like visitors. And then you get into a small office, and they may have 10 users and 10 machines. Both are LANs. It's just they're different in sizes. When we talk about WAN, a WAN is a wide area network. It's anything that's going to cover a large geographic area. So the Hattiesburg campus is a LAN, but it's interconnected directly. So we have a point-to-point connection between Hattiesburg and Gulf Park. There's nothing in between those connections. That's a WAN that's in between the two because it goes from Hattiesburg all the way to Long Beach on the coast. So hopefully that helps with a WAN. The biggest WAN of them all, the internet. So LAN, again, is a network infrastructure that spans a small geographic area. WAN is going to cover a large geographic area, and you can see that they give you some examples of what happens and where the differences are. Oh, this is another good point. So LANs, when they first started, were 10 megabits per second. So we could only move 10 megabits at a time. And just so you guys get an idea of what 10 megabits is, it's like downloading something on a UVerse connection. You're probably getting about 10 megabits of bandwidth. So our old LANs, that's as fast as we worked. A new up-to-date LAN, we're getting 1 gigabit even through the air in some places. So I can transfer 1,000 megabits. So there's a lot more speed available when you're on the LAN and you're moving stuff between devices on the LAN. Whereas when I leave the LAN and I get on a WAN, it's going to be a slower bandwidth. Now, I say that, but a WAN now, 1 gigabit is not unreasonable. It's about $1,500 a month for a 1 gig fiber connection to a building if you're located correctly, if you're in the right geographic location. A LAN, however, on the backbones, so the big expensive parts of a LAN when we're moving stuff from building to building, floor to floor, outside of a classroom, for example, some backbones are now 100 gigs or more, 100 gigs. So that is a considerable difference in speed between the LAN and the WAN. Everybody knows what the internet is, so I'm not going to spend a whole lot of time on what it is, but it's made up of copper, fiber, and wireless transmissions. So examples of wireless on the WAN side would be your cellular transmissions and your satellite connections. So when you talk about a dish internet connection or a Wild Blue, those would be satellite wireless communications that are WAN because we're actually getting on the internet over a satellite. Again, your cellular hotspots that you're traveling around with, or in your cars even now, are wireless transmissions. Almost everything copper hits fiber at some point, but it's not true fiber. So a fiber connection would be fiber in your actual house or inside your business. That is possibility in some locations now, even in Mississippi. A copper wire example of a WAN would be your old style T1s. Most of those things have been phased out unless there's some technological holdback. So for instance, some places haven't changed out their software and their hardware, and it requires those copper connections to function. Because believe me, people would want to flip to fiber if they could. A 10, 20 meg fiber connection, probably roughly around $400 or $500 a month. A 1.5 megabit T1 is probably $1,000 to $1,500 a month now. They've actually, copper connections have gone up in cost because they don't want you using that. It requires more service on the provider side of things. UVerse is an example of a copper thing, but it's only copper to a point. UVerse eventually does jump on fiber some places. Your coaxial Comcast connection, if you have a Comcast connection here in Hattiesburg, is an example of a copper WAN connection, but it's copper in the inside of your house and then maybe some parts of the outside, but eventually it's going to hit fiber and have a fiber backbone. That's why they can provide the speeds that they do. Another thing that we need to do some research on and understand is all the different organizations that make up the rules for the internet. 3 of these are listed right here. So there's IETF, ICANN, and IAB. And I'll let you guys kind of go out there and do the research on those things. So lastly, when we're talking about types of networks, we have the internet, which is the world. The world can sometimes connect back to our corporate offices, but we typically don't let them on the inside of the company. So only the students and staff and faculty members of campus should be connecting to our intranet. Okay. We do have an external piece to it in some senses, and in that external piece, so SOAR would be an example of something that would be out here in the extranet that we provide a connection to you so you can access it anywhere in the world. Canvas would be another example of something that we would house on an extranet because we want you to be able to connect to it from either outside or inside the campus. So I'm just using those as examples. So think about it this way, anything internal that you need to give to somebody outside, so for example, a company that has outside sales reps, those sales reps need to be able to hit something at the extranet and then move data onto the inside. So all the sales at the end of the day need to come off the internet, hit the extranet site for the sales reps, where they would put in their sales information, and when they hit submit, it would actually get transferred from the server that's on the extranet into the internal part. Anything that's super private and confidential should only be available to the intranet and people that are actually sitting in the intranet. Should not be available extranet or on the internet. So, and I'll let you guys read the blurb there on the slide at your own leisure, but I kind of defined it in my own terms there.